Good afternoon, dear students. Today we are going to study a topic in the subject of building services, and the name of the topic is hot water supply in buildings, and we shall also have a look at how water can be heated through solar means. We are all very familiar that nowadays you have rooftop solar water heating systems available. So, in today's lecture, in today's presentation, we will see the various types of systems to have hot water supply in the buildings and also touch upon solar water heating. I hope after today's lecture you will be little bit wiser on how to design a hot water supply system also. Although it is the job of a public health engineer, you need an engineering input to be able to design, but as an architect I believe you should know the system requirements. So, as a architect you are to tell the engineers that this is my requirement of hot water, then only he or she, whosoever the engineer is or public health engineer, will be able to deliver the requirements to our satisfaction. So, we start with basically in today's presentation we are going to cover a brief introduction about what hot water supply is. Then we will see how to design a hot water system, what factors are to be considered, and then it is very important that the size of pipes, how it is determined in case of hot water supply. Just like in cold water supply, you are aware that in residences you normally have a 1-inch pipe or a 3/4 inch pipe and half-inch pipe. Similarly, in hot water there are different sizes which are used according to the specific need. Then we will also see the different types of systems and have a look at the requirement of hot water, how it varies with the type of building basically. And then we will also go on to see this is a very important and major aspect in hot water supply in buildings, that there are a lot of water heating system losses. So, when you heat water at a certain temperature and at the faucet level, that is the level where you need the output, there will be a drop in temperature significantly if you have a central system. In case you have a normal water heater like in a residence, there the temperature drop or the system loss will be minuscule, but in case of a big building like a hotel or in case of a building like a hospital where you need 24-hour supply of hot water, there it is very important to minimize the losses at the production level and at the utility level. So, there are issues about operation and maintenance which shall also be covered, and then we will go on to have a look at hot water supply in residences and in hospitals, in hotels, and also as I mentioned we will touch upon the solar heating of water to have hot water supply in our buildings. So, before we commence with today's presentation, I will ask you one simple question. You all have used hot water in your toilets. So, on which side of the wash basin or on which side of a bath should the hot water tap be? Should it be on the left side or should it be on the right side? So, it is that very important that there are international norms, but as architects or as students of architecture, we are just not even aware that whether the cold water tap should be on the left side or the hot water tap. But if you go to a 5-star hotel, if you go to a hospital which is of repute run by an MNC, there are certain norms. So, I leave it a question to you as students of architecture. I am not going to tell you the answer, that hot water supply is an essential component of water supply in buildings, and as architects we are not even following that on which side, whether on my left hand side or the right hand side, the hot water tap should be there. But there is a certain code, there is a BIS standard, there are international norms. It just does not happen that in some building you can have it on the right, on in some other building you can have it on the left. So, please be aware students that it is a very important thing. A hot water supply system needs to be understood, needs to be designed, and today's presentation I hope will give you some idea about the basics, and then you can explore yourself in the books and on the internet, become more wiser. But suffice it to say, when we are looking at this slide, that it is a very important topic, it cannot be ignored, and as students of architecture you need to have in-depth knowledge. Of course, the engineers I have told you, will be supplementing, but we are to tell them the requirements. So, let us move on to the introduction. It's very simple that water heating is a thermodynamic process that uses an energy source to heat water above its initial temperature. The normal water supply which you are getting from the municipal mains will be at the temperature according to the climate. In summers it may be at a particular temperature, maybe about 7 to 8 degrees centigrade. In winters it will be at about 4 degrees centigrade. So, when you need hot water supply, you have to heat this water which is coming from the municipal mains, and you have to use a source of energy, and this is what is the basics of water heating. So, typical domestic use of hot water include in cooking, for example, in hotels, cleaning, bathing, space heating, and when you talk of industrial use, in industries hot water and water heated to steam may have uses according to the industrial processes going on. So, appliances, you read at the bottom please along with me, the appliances that provide a continual supply of hot water are called water heaters. They can also be called geysers. They are also called hot water heaters. These are different names by which they are known. They are also known as hot water tanks, as boilers, heat exchangers, geysers or calorifiers. So, a more technical name is calorifier. So, these are all exchangeable terms, please understand. You may refer to it as a geyser. If it is giving you hot water, you may refer to it as a heat exchanger or a boiler or a hot water tank. So, these names depend upon the region and whether they heat potable or non-potable water. For example, if you need water for cleaning the utensils in a kitchen, there you may not need potable water. The term potable means drinkable. So, non-potable water, if it is being heated, then the name will be accordingly, and whether they are in domestic use or in industrial use, and what is their energy source. So, for domestic installations, potable water heated for uses other than space heating is also called DHW, that is domestic hot water. So, that is briefly the introduction of hot water supply in buildings. I must remind you, dear students, that of all the types of buildings which an architect can design, or of all the types of buildings which human users use, 50% of these buildings comprise residential or apartments or houses. So, please understand the importance of this fact that all other buildings are 50%. In this, all other would be hospitals, hotels, shopping malls, commercial, and all the other types of airports, railway stations, terminals, whatever you can think of. But the major chunk, 50% of the buildings is the residential buildings or the houses for people like you and me. So, when we are talking of hot water systems in buildings, we need to be aware that there will be a separate set of requirements or separate set of systems which will be applicable for residential use, and there will be a different type of procedure and the type of systems or the equipment which will be required for buildings other than residences. So, as I told you in our presentation, we are going to study about hot water supply in hospitals also, number 10. Number 11, we will study in hotels also, and primarily we will study. So, let us come down to the sub part 2, design of a hot water system, maybe for residential or for non-residential. What does it comprise? So, you have to determine the demand of the hot water, what is the quantity in terms of liters, and what is the temperature at which water is required. So, this is very important. Then to select the type, capacity and heating surface of the calorifier or the heat exchanger, or the, as I said, all these terms are interchangeable, or the geyser you can say in case of a residential use. Third is selecting the water heater or boiler and design the pipe scheme and the pipe sizes. So, from this slide I think it is quite evident that the framework in which an architect has to proceed is, number 1, you have to know the demand. So, how demand can be known, we will also study in today's presentation, that how much water is required for human use. Let us say For example, if you studied cold water supply, then you must be aware that the quantum of water required per person per day is normally 200 liters in case of a city of population 10 lakhs. So, similarly, we are to know the requirement of hot water, because the system which you are going to design will be based upon the requirement. So, and secondly, of course, the temperature at which water is required is also important, and then accordingly we move on to selecting the type, capacity, and the heater and the boilers, and also the piping and the scheme of the piping. So, the key factors to consider obviously are: number one, as I have been saying very frequently, the quantity. So, whether that quantity you need as instantaneously. So, hot water can be generated instantaneous. There is something called instantaneous hot water supply. You must have seen in your residences there are small geysers available which you can just fit on the tap itself, or they can be fixed a little bit above the tap, and if you have indirect water supply, then you can have instantaneous hot water. So, then you can also have storage type of water heaters in residential situations. So, the quantity which is required, first you have to consider that, and then the temperature. Normally the temperature of hot water required would be 55 to 65 degrees centigrade. Now, this is important dear students, because we all know that at 100 degrees the water starts boiling, and it is almost impossible to touch the water at 100 degrees, and the ideal range I would say is from 50 to 60. For example, if some of you are using your automatic washing machines, there is a temperature selector, that there is a heater inbuilt into the automatic washing machine. It can heat the water up to if you go home and notice today, it starts from about 40 degrees to about 70 degrees. So, these are the normal temperatures for hot water supply, which are ideal from many standpoints, right. So, then the next factor to consider, of course, is the cost of installation and the maintenance. As I was saying, that there are issues of maintenance. Let us see here in the at number 8, you will see operation and maintenance we will be covering today, because what happens is that in hot water supply, the source water may not be of very good quality, and then there are traces of nitrates, chlorides and sulfates which are left on the bottom of the heating surfaces of the boilers or the heaters or the geysers, and they need to be periodically maintained. So, cost of installation and maintenance, this maintenance also is an important point to be considered while designing the hot water supply. And fuel energy requirements and running costs, of course, what kind of fuel you are using. I think as students of architecture, the first fuel which comes to our mind is electricity, but no dear friends, if you have been on class tours to some cold regions like Srinagar or Leh or to Simla, then you must have seen that the hot water which is supplied in hotels or in residences in very cold regions does not get heated by electrical means, it gets heated by other means, for example, by wood, firing by wood. So, the fuel, what kind of fuel, and maybe gas can also be used, and I am sure if you have been to certain building product exhibitions, you must have observed that there is a new trend, that you have a geyser being run on LPG. So, natural gas or a liquefied petroleum gas could be a source for heating the water, right. And then of course, conservation of water and energy is one of the key factors to be considered, and also the safety of the user. The system should be designed in such a way that at all times the user of the system is safe. Like for example, if I touch the tap and the water gets there obviously will be a thermostat when we are talking of this range of 55 to 65 degrees. So, the at 65 degrees and above, the hot water there would be a thermostat, it would cut off further heating, or even if heating is happening in the supply end, the water would not be more than 65. But then if the thermostat fails or there is a maintenance issue with that, then the tap itself or the faucet from where the hot water is coming out has to be of such a nature that the safety of the user is ensured. His hand should not get burnt, or he should not have a burn injury by putting on the tap. So, these are some of the factors which I hope you all understand, that the quantity of water, the temperature, the cost of installation, the fuel or the energy, the type of fuel energy used, and to conserve the water and energy. Here we would of course recommend, I think you must be very much clear by now, here we could go in for solar water heating, and also the safety of the user. So, let us have a look at the hot water pipe sizing. When the flow rate required is about 20 liters per minute, this could be in the case of, let us say, your normal bathroom. There the pipe size could be 0.75 inches, pauna inch, or 20 mm or 19 mm, and as the flow rate increases, then you could have maybe a pipe of up to 3 inches thick supplying hot water. This of course would be in case of a industrial requirement, or in case of a, let us say, swimming pool in a hotel which has to be filled up with hot water. There you will need a pipe of about 3 inches. Now, why we are trying to study this as architects is that it is very important that the pipe which is carrying the hot water, it itself has to be insulated. It is itself a source of losses. So, let us study what is written beneath. The sizing of hot water supply involves the same principles as the sizing of cold water supply. The piping system should be capable of meeting the probable maximum demand at an acceptable pressure drop and water flow velocity. The secondary return pipe is sized on the basis of flow rate required to offset the heat emission from the pipe work, including the flow and return rates. What this simply means is that the pipes which are conveying the hot water, you need to have an accurate design for them. They should neither be too big, neither be too small, to be able to deliver the exact quantity of water required at the exact pressure desirable. And if we do not do that, now this is not the job of an architect, I must apprise you. These issues are left to the discretion and the design of the plumbing engineer or the public health engineer. So, but still nevertheless we need to know that as an architect the minimum size would be about 3/4 of an inch, and the maximum size would be 3 inches, where the flow rate would be very heavy, there we would use 3-inch pipes. Now, let us come down to the systems of heating of water. There can be instantaneous and storage type water heating systems. I think I mentioned in the beginning also the normal types of water heaters or geysers we are familiar with in a domestic installation. In a domestic situation, we go in for this, either the instantaneous or the storage. So, storage systems would have about a big tank, about 30 liters or 40 liters, available up to even 50 liter capacity, and starting from as small as 15 liter capacity. So, that can be one type. The second type, we could have central systems or local systems. This is now applicable to non-domestic type of hot water supply, where let us say in a hotel you would want to have a central hot water system, hot water supply system, or there could be a local system also, depending upon the period in which the guests would be there or not be there, whether the hotel is functioning to optimal levels or there is a decrease in the number of inhabitants there at a particular time. Then you could also classify the systems as gas fired and electric. So, this is very simple, of course. I hope you understand that the normal method of cooling the heating the water would be electric, as we are very familiar, but you could also have a gas fired system. Then there is also an issue of whether to go in for a vented or a non vented system. Since lot of pressure is going to be generated in the system when you heat up water, there needs to be a vent, but in certain situations we could do without a vent also, because the vent itself is going to add to the cost of the hot water supply system. So, it will depend upon what is the type of situation where we are designing the hot water supply. This chart elaborates on the types of the hierarchical slide, which is showing hot water systems on top. Left side you have the storage type, right side you have the instantaneous type, and then you have vented, unvented. So, I will not go into too much detail about this, because it is going to take a lot of time, but what is important to be known is that primarily we have instantaneous, that is spot, or primarily immediate. Instantaneous means immediate water heating. For example, the visual you see on the right side, there is a small, you can see a tap, but it has an inbuilt instantaneous heating system. So, what happens is there is a this works on electricity. So, there is an element which is, but obviously it has its limitations, that the quantity or the volume of water will not be too large, and the flow of water will be not to that extent as you can get in a storage type. So, dear students, please understand that you could have a water heater in such a small unit itself. Now, this is the beauty and this is the ingenuity of engineers and architects. We need a certain solution and it is designed. So, please be aware that you do not need huge water tanks or boilers in case of domestic use. You could have standalone separate systems like this one. So, this chart gives us of all the permutations and combinations of multi point, single point, and then inlet control, outlet control. I will not go into too much detail, you can have a look at this in the presentation later on, but what is important is that there will be central and local. First, instantaneous and storage type, then the classification would be central and local, and also whether it is the heating is done by electricity or non-electricity, and whether the system is vented or unvented. So, let us move on to instantaneous. So, water heated is, you have all seen this, I think many of you have it in your residences. It is a small contraption, about, let us say it would not be more than 1 feet in height and about 7 to 8 inches in width and depth, 6 inches in depth also. So, water heated instantaneously, no storage is permissible or possible, and heating element has to be designed to satisfy maximum demand. Now, compare this with such a big kind of situation. Nowadays, the students, architects are not placing the storage type water heaters within the toilets. New trend which is coming up, and you will be doing the toilet details also, this is placed outside the toilet, so that it is not visible, and still it is connected, and if it is fired by, let us say if it is heated by a LPG system, then there will be a housing or a space created outside the toilet to have that cylinder also in place. That cylinder may not be your normal 14.2 huge cylinder, it could be a small cylinder. So, the amount of LPG used is very minuscule, because it is not going to, you are not going to need the water the entire day. So, a small cylinder of 5 kgs would even be sufficient for a month's duration. So, but the whole thing which I want to point out here or bring to your notice is that as students of architecture, we need to aware how these systems get fixed, where they are hung. So, there is a lot of detail, but today's lecture of course is not going to deal with all such issues. We are trying to understand first of all today the basics of hot water supply, how it is done. So, you have the instantaneous system where no storage is permissible or it is not designed for storage, and you have something like this on your right side, very conventional type of reserve storage for hot water is there, used when large quantities of water required at intervals and used where reliable supply desired. So, it depends upon the choice of the client or your customer, that what kind of system you would prescribe to him, but as an architect you have to be very sensitive, and you have to determine the type of requirement first and then give a solution accordingly. In most cases, our role as architects would be important to have this placed in the right location. Whether you want to put it inside the toilet, then the piping and everything has to be done accordingly. If it is to be done from a remote location, maybe about 3, 4, 5 feet outside the toilet, or maybe you have a surface outside where you could protect it also from the weather and climate, then that's a much more desirable kind of design solution. Okay. Then as we were saying, there are instantaneous storage, very simple, central and local. So central systems comprise of a boiler or a water heater of some form and has a network of circulating pipe connections, the storage to the outlet points which may be many. So the visual on your left side shows that you have a input and there is a boiler, and then there is a pump which is taking the hot water up, and then it is supplied, and also additionally there could be indirectly heated cylinder also. So this is what is meant by central system of hot water supply, where at individual taps or individual faucets you do not have a geyser or an instantaneous or something like that, or a storage type. It is done at a central location. Now water heated adjacent to the outlet, this may, let us see, comprises a boiler or water heater of some form, has a network of circulating pipes connecting to the storage, and then water heated adjacent to the outlet. You could also have a central system, sorry, this is the local system where water is heated adjacent to the outlet and may involve some storage vessel. So this is also in vogue, but it is of a different type. This is a bigger blow up of the previous visual, and this hot water may be required in radiators for HVAC control in the rooms also. So you can see that this red line is going to the radiators also. Radiators, dear students, here means the air conditioners which are going to supply hot air in the winters. So a central system makes sense when you have hot water running to your radiators and then supplying hot air into the interiors. Now the centralized, let us see the advantages of centralized system. Provide large bulk of storage, requires less maintenance than several units, of course there is one unit only. Cheaper fuel can be used, easier to integrate renewable technologies like solar water heating, this can be integrated into the central system. Disadvantage is long length of secondary pipework which can lead to heat losses. That is very much evident, because as you see from this visual, the pipes will go all around the building. So lot of pipe work will be required and there are going to be losses. Compare this with localized system. Here the advantages are maybe fitted close to the fittings being supplied, saving in boiler house space and possible fuel storage. And here, like in the centralized system, this would be more desirable in case of a hospital situation, but when you talk of residential situation, apartments, their localized solution would be more appropriate. So saving in boiler house space and possible fuel storage, no need for secondary circulation and long dead legs. Disadvantage, separate gas or electricity connection required for each heater, of course you will have to do that. Greater risk of fire inside the dwelling due to more gas or electrical connections. So the trade off will depend upon the type of building and the number of places where we require the hot water supply. If the faucets are few in number, then we might go in for the localized system, but wherever there is a need for continuous 24-hour supply, there it will be desirable to have a centralized system. So these are some details about the gas fired and electric system. You can notice in the visual on the left side, adequate supply of combustion air is important, because when you are trying to heat up the water, there is going to be a pressure also created, and there is going to be the combustion air. You will need air for burning the fuel, whatever fuel you are using. So it is very important. So have atmospheric burners or forced draft burners, and can serve a single outlet or several outlets in a flat. And water temperature is controlled by means of adjustable thermostats. Electricity cuts when predetermined temperature is reached, and designed for use in local heater. So, this is the detail about the gas fired and electric type of hot water system. I do not see too much use of this in India, because here the climates are normally, most of the country, the climates are warm, and you need hot water supply only in winters. So, and also the